Hello, I'm Rithika from Northeastern University in Boston. My presentation today is on the potential applications of context-aware messaging to improve physical activity in individuals with spinal cord injury. This work was done in collaboration with Temple University and Philadelphia. In this formative work, we found that current physical activity tracking technologies are not inclusive for individuals with spinal cord injury. Communication about physical activity is often initiated by individuals with SCI, and scheduling messages to be delivered later based on own context could help initiate conversations and provide updates about physical activity. SCI affects more than 250,000 people worldwide every year. It limits mobility and autonomy of persons affected and can lead to secondary conditions such as chronic pain or depression. Higher levels of physical activity in individuals with SCI have been associated with lower levels of pain, fatigue, and depression. From prior work, we know that barriers to physical activity include pain due to injuries, lack of time and energy, needing assistance, lack of information on safe exercise guidelines, and the accessibility and availability of resources needed for exercising. Behavioral interventions in the past have used self-management techniques and exercise training programs to improve physical activity with varying degrees of success. These are not very scalable. Researchers have also been continuously working on improving accuracy of physical activity detected by sensors in wheelchair-based physical activity. However, there has been limited research that has leveraged these advantages to deliver interventions. Fire was one such application that used a smartphone and a smartwatch to detect activity automatically and deliver just-in-time feedback. We also know that social support can increase physical activity levels. Therefore, delivering just-in-time social support based on automatically tracked physical activity and other events could be effective in improving physical activity levels. Our research questions were: 1. How might novel communication tools be used to help individuals with SCI overcome some of their barriers to engaging in PA? And 2. What role could timely encouragement and support from peers and supporters play when developing systems intended to promote physical activity among individuals with SCI? Our study consisted of two phases. Phase 1 involved semi-structured interviews, and Phase 2 involved participatory design sessions based on data collected in Phase 1. Individuals with SCI who use manual wheelchairs were invited to participate along with a friend or family member if available. We conducted a total of 4 sessions with each participant. In Phase 1, we asked participants about motivators and barriers to physical activity. We asked them to rank barriers to physical activity, and we asked them how communication could help overcome some of these barriers. We used the data collected in Phase 1 to design storyboards for Phase 2. Some of these storyboards in Session 3 included message scheduling based on recipient context, templates to aid message creation, and a forum to connect with other individuals with spinal cord injury. On this screen, we see 2 concept screens presented in a storyboard where participants were asked to schedule messages based on recipient context. So on the left, you see that the participant has an option to schedule messages to Bob based on time, physical activity, or location. And on the right side, we see that the participant chose to schedule the message based on time and that the message will now be delivered at 2:30 p.m. In Session 4, we continued with storyboarding. We showed participants storyboards for the preferences for receiving scheduled messages and message scheduling based on own activity or context. This storyboard was included based on feedback in Session 3, where participants wanted to schedule messages based on their own activity. We had a total of 87 interview sessions, which resulted in 42 hours of audio with a mean interview length of 29 minutes. And 2 independent researchers coded the interviews, labeling emergent phenomena based on reflexive thematic analysis guided by our research questions, with elements from grounded theory. We had a total of 15 participants with SCI and 8 friends or family members. Out of the 15, 13 were male, 2 were female, with a mean age of 47 years. In phase 1, some of the participant quotes here have been included. P7 said, "For me, I know these women I've been doing rowing with. Just having someone there with me, whether watching or just being with me, holds me accountable and makes me want to do it. Not for myself, but for the other person as well." P1 said, "I use an Apple Watch, and if everyone is competing against how many steps, and if you're not taking steps because you're in a wheelchair, then you don't have that option to compete." Major themes that emerged in phase 1 were physical activity to facilitate social interaction and make meaningful connections. This could either be through competing with others or by working out with others. And the lack of consumer-facing technologies to easily track wheelchair-based PA. In phase 2, participants were asked about communication. P3 said, "If you're having pain, maybe talking about it with somebody else, could help you figure out a better plan to go with your exercise or activity. Communicating rather than trying to figure it out on your own might be nice." P16 said, "I would rather receive the message close to the time that I finish the PA. I think it'll motivate me more to keep doing it, whereas if it's like hours later, I'll probably go, whatever." Major themes that emerged in phase 2 include using communication to overcome barriers to physical activity, and that context and timing influence a message's perceived impact. For example, receiving a congratulatory message based on automatically detected physical activity when the session didn't go well would make these messages sound ungenuine. Coming to design implications. Firstly, real-time social support can be used to increase physical activity levels by making users feel more connected and providing timely motivation to exercise. Users also suggested that receiving messages based on goal completion can be motivational. Secondly, facilitating meaningful conversations using templates. We showed participants templates to help them start conversations about physical activity. There were 2 types of templates. On the left, you see the fill-in-the-blank style templates inspired by Mad Libs. And on the right, you see the question style templates, which allowed more open-ended responses. Participants preferred the question style templates because it didn't make any assumptions about how the recipient's activity went. And finally, context-aware messaging can provide tailored opportunities to start conversations by allowing people to schedule messages based on their own physical activity. And it also provides a way of exchanging information about safe physical activity. In conclusion, through this formative work, we found that current physical activity tracking technologies are not inclusive for individuals with SCI. Communication about physical activity is often initiated by individuals with SCI, and scheduled messages based on own physical activity can be used to both initiate conversations and provide updates. This work would not have been possible without generous funding from the National Institute on Disability, Independent Living, and Rehabilitation Research. This is a full list of all references cited in the presentation for anyone who wants to refer back to it later. Thank you.